For this video, we're going to look at standard deviation and how we can find the standard deviation of our data set. So to begin with, the basics. Standard deviation measures how spread out the data is from the average. So we're looking at that mean and we're looking at how much the data deviates from the mean. The basic example is if we know the data has a mean of 100 and a standard deviation of 20, we can figure out what that data set is going to look like, all right? See how spread out the data is. Couple things to talk about first before we get into standard deviation is we have the normal curve, which is our bell curve, right? And it's symmetrical. Right in the middle of that normal curve is our mean. All right, so there's the average of our data, and it's the same on both sides, or pretty close to the same. Okay, in a normal curve, the mean is also the median. Okay, the average of our data is also the middle of our data, and it's right in the middle, symmetrical on both sides. If the mean is pulled one way or another, that means that there's some values that are making it higher or lower, and they're kind of stretched out here. They could be outliers. All right, so for this bottom left example, it's pulled out to the right, so we're saying it's skewed right. And that means that the mean is higher than the middle of our data, where the median is. The opposite of that is if the mean is below the median, and we have something pulling it to the left to lower the mean. So something maybe outliers or just a lot of data over to the left, and that's going to make it be skewed left. With that normal curve, right, where our mean is right in the middle, we have what we call the empirical rule, and it has to do with standard deviations. So if we say each of these tick marks is worth one standard deviation, this first tick mark on the left and the right, they're both the same distance from our mean. They're one standard deviation away from the mean. Within this red to red area, okay, we have 68% of our data. Okay, so just using our empirical rule, 68% of our data should be between or within one standard deviation of the mean, whatever that standard deviation is. And we can go high and we can go low. Then if we go another standard deviation over, so now we're two standard deviations over. Okay, so if as long as it's within 2 from that mean, we're looking at 95% of our data. So the majority of our data, almost all of it, is within the 2 standard deviations of that middle mean. We can even get a little more specific, right, and say that one more standard deviation over is actually going to be 99.7%. So I don't want to do too dark with the black. But from 3 standard deviations, we have 99.7%. So almost all of our data, minus a few that might scooch out on the outside. Okay, so the empirical rule says that 68% of the data, most of the data, is in one standard deviation from the mean. Then 95% is within 2, and then 99.7 is within 3. So a better picture of that, with all the numbers broken down, we have 68% in the middle, we have 95% within 2 and 99.7% within 3, and this part right down the middle, that's our mean. All right, that's the middle. Now, you see that we have these different symbols here. This M-looking symbol, that's a mu, that's our mean. That's a symbol for mean. This is actually for the population. Remember we talked about on the calculator, we have X bar. This is a sample mean for a sample, and then the mu is what we use for the population. Right? Likewise, we have this symbol over here that's actually for standard deviation. So this is plus 1 standard deviation, minus 1 standard deviation, plus 2 and 3, and then minus 2 and 3. Right? And then for a sample for standard deviation, we just use S. Right? So these two are for our samples, and these two are for our population. Right, which we'll get to a little later on. But this has it broken down nicely for us. So it's 68% is within one standard deviation of the mean, which means that each half is 34%. So if we go from the mean and up 1, we have 34% of our data. Okay, and likewise, we have half of 95, right, minus the 34 gives us 13.5%. Right, because if we added those together, we would get 47.5%, which is half of 95. So then that leaves this one section from 1 to 2 below the mean is 13.5%. I would draw this somewhere so that you can have it handy in your notes when we come back to it in class. Okay, you should be able to figure it out quickly because we know it's 68, 95, and 99.7, but this wouldn't be a bad thing to have handy. Alright, so a couple applications. A sample of 1,000 people were surveyed on how many TVs are in their house. If the data is normally distributed, so that means it follows that bell curve, with a mean of 3.5 and standard deviation of 0.5, approximately how many people would have between 3 and 4 TVs? So all we're going to do, draw the bell curve. Okay, right in the middle, this is our mean, which was 3.5. So I can put a 3.5 right in the middle. Then to go one standard deviation over or up, when our standard deviation is 0.5, takes us to 4. And then one more up would be 4.5. And then one more would be 5. Same thing going down. One down would be 3. Then 2.5 and 2. I want to know how many people have between 3 and 4. Well, 3 and 4 is this section here. Okay, which is within one standard deviation, so that means it's 68% of our data. So I want to find 68% of 1,000, which I know is kind of easy because of the 1,000, but anytime you want to find the percent of something, just multiply. We'll put 68% as a decimal, so we have 0.68 times however large our sample is, so 0.68 times 1,000, 3 zeros, move your decimal 3 over. So approximately 680 people, let's get rid of that little line there, 680 people have between 3 and 4 TVs. It's approximate because that's not necessarily the case, but because it's normally distributed, we can use the empirical rule to estimate. Alright, so the scores for all high school seniors taking the verbal section of the SAT a particular year had a mean of 490 and a standard deviation of 100. The distribution of the scores is bell-shaped. Alright, so we'll take a second to sketch that out. Here's my curve. Right down the middle we have our mean of 490 and a standard deviation of 100. So as I go up, I'm going up by 100. So we'll go up a couple times, and maybe one more. And we'll go down a couple times. Okay. Now, we want to know the percentage of seniors that score between 390 and 590. Okay, well 390 and 590 is going to be right in the middle between one standard deviation of the mean. And we know by the empirical rule that that's 68%. One student scored 795. How did this student do compared to the rest of the scores? So 795 is going to be way up here somewhere. Right? So how did they do? They did awesome. They were way higher than everybody else. Okay, most of the students were in this middle section. In fact, 99.7 were between 190 and 790. Right? So having 795 means he was in that last 0.3%. Right? So he did awesome. A rather exclusive university only admits students who were among the highest 16% of the scores on this test. What score would a student need to be qualified for admittance? Well, we can kind of go back to this one. Okay, we want the highest 16%. So if I take 2.35, 0.15, and 13.5, that's going to give me the 16% that's up here. So when I go back to that problem, I want to know the ones that were above one standard deviation. So we'll go back. One standard deviation away is 590. So in this case, the student would have to get above a 590 to be in that top 16%. Alright, finding standard deviation. Guess what? We can use a calculator, luckily, because this just looks like a hot mess. Alright, but let's think about what it means. Finding the standard deviation for your population, we're going to have something that we take the square root of. Okay, this symbol here, x sub I, that's talking about each one of your data entries. So each part of your data set. And we're going to take each number and subtract the mean. Alright, that can give us a positive or a negative, depending if it's above or below the mean. But we take that number and we square it. So we do that for all of our entries in our data set. Okay, square it. Then this E looking thing is sum. So we're finding the sum of all of our points minus the mean squared. Okay, then we take all of that and we divide by the number of terms that we have. Okay, the only thing that changes when we go to our sample is that we divide by n minus 1. Okay, and we can also use our calculator, our one variable stats, which we've seen already. So we'll go and use that for our first one. Okay, so we've got the mean and standard deviation of 5, 7, 8, 14, and 16. So we're going to enter it into the calculator. Okay, so I'm going to go on my calculator to stat, and I want to go to edit, so I can enter everything in. And we have 5, 7, 8, 14, and 16. Alright, so then I'm going to go stat, calc, one variable stats, and let it load. Okay, so it tells me that my mean is 10. Alright, so I'll come here. My mean is 10. And we'll scroll down, or so if you look down, it tells us the sum of all of my numbers, the sum of all of them squared, right, which is part of the formula for finding your standard deviation. And then we have the S and then our symbol here. We're going to use the population. Okay, we want to use the population. So in this case, it's 4.2 for our standard deviation. All right, let the calculator do the work for you. Alright, so for this one, we've got 22, which is about to get covered up. So I'm going to go to Stat, Edit, 22, 24, 19, 18, 17. And we're going to go to Stat, Calc, one variable stats. Alright, my mean was 20, and my standard deviation is 2.6, which is right here, answer choice B. Alright, understand standard deviation. The higher the standard deviation, the more spread out your data is. Okay, so it's less peaks. So it would look more like a flat bell. Okay, because that means your median's in the middle and your standard deviation is large, so it's farther apart. Right? The lower your standard deviation, the less spread out your data is. So it's more peaks. So we get this kind of tall where the mean's in the middle and your standard deviations are closer together. Okay, so standard deviation is talking about the spread of your data.